Hello everyone, welcome to 2022 Summer Robotics Class Info Session. My name is Janet and I'm going to be your host tonight. So here's tonight's agenda. First, we will do a quick introduction about XCamp and the new robotics program. Then our guest speaker, Dr. Jin, will share the benefit of young students to learn robotics. After that, we're going to have Mr. Chen to share more details about the robotics class. At the end, we will have a Q&A session. Since we have a full agenda tonight, we do ask the audience to ask the questions at the very end during the Q&A session. During the presentation, if you have any questions, please feel free to type them in the chat window. We will get them answered at the Q&A session. And this session is recorded and it will be shared to the parents and the students when it is ready. So with that, let me quickly give an introduction about XCamp. XCamp is founded in Silicon Valley and it is focusing on mastering of data structure and algorithm. It offers coding classes for middle and high school students to achieve success at contests such as U-Cycle and beyond. So far, we offer classes from CX 100 to CX 600 for fifth grade all the way to 12th grade. And this summer, we are very excited to introduce to all the students a new class for robotics. And here are a few highlights for this class. So this class is focused on systematic robotic system training to prep students for robotics competitions. It will teach the kids the principles of all the components, the key components of robotics, and how to control the program and program all type of components. It also teach the kids a system design and design software to real-time control the robotics tuning and troubleshooting. And also this class will use modeling and simulation to help kids to get hands-on. And a plus is for the kids who does not have C++ experience, don't worry. We'll teach the kids we will do the introduction to C++ for the robotics programming. So Mr. Chen will go through each of them in greater detail in a few minutes. This is just a very high level highlights of what this class will be covered in the summer. So with that, we are very honored to have Dr. Jin as our guest speaker tonight. Dr. Jin is a professor in Department of Electrical and Computer Engineering at University of Texas at San Antonio. She has more than 18 years of research and teaching experiences. And besides her professional life, she has two beautiful children and she helps coaching FLL in her spare time. So let's hear from Dr. Jin on the benefit for kids to learn robotics.
Good evening, everybody. I'm Janet. Thank you for your nice introduction. It's such a pleasure to introduce the significance of learning robotics for middle schoolers and high school students. So in this figure, I showed how the robotics has been evolved during the past 50 years. You can see at the beginning, robots are working on single task, and the motion of the robots is more driven by the wheels. As time goes by, you can see the robot stand up, and then it walks, and then right now it's jumping, bouncing, and have the back flipping. I will show you a video very soon. But let's go back to the trace of robots. Robot is defined as a design, construct, and use machine to specific tasks. The first robot was built 5,000 years ago in Egypt, where they used human figurines to strike the hour bells for time measuring. We have the Egyptian water clocks which is the first clock in the human history. As time goes by, people have thinking about robots, but the modern robots was proposed by George Devil. He found a company called Universal Automation, and he proposed to have reprogrammable manipulator called Unimate. Unfortunately, Unimate was not a success until 1960s because George sold his company to another IP lawyer, and then it was the IP lawyer makes the company success. Next slide, please. So I found a very interesting video in YouTube. It was developed by Boston Dynamics. It shows the latest advances of robots. So let's look at the video together.
Okay.
Okay, you can see that during this video, there are two robots, and you can see that the knee joint of the robots is not like what you are as a grown up, but it looks more like a toddlers, because when you start to walk, you can see the toddlers always have their knee joint kind of bent. And the reason is because when you walk, it's very hard to control the gravity center of the body. And then you can see it from this latest video by Boston Dynamics. And this is one of my favorite companies with advanced technologies. Okay, next slide, please. So as I showed in the previous slide, we can see at the early stage of robots, modern robots, we can see the robot is driven by wheels. And this gives us a fundamental idea of autonomous vehicle, which is a special car-like robot. So robot is a very large area, but within the area of robots, autonomous vehicles will be or have been defined as one of the booming area. So what is autonomous vehicle? Autonomous vehicle is defined as vehicles can guide themselves from one place to another desired place by human beings. It's also named as self-driving cars, robotic cars, or unmanned vehicles. Even for unmanned vehicles, you can have unmanned air vehicle, unmanned ground vehicle, or unmanned underwater vehicles. There are all kinds of vehicles you can think about. Another thing I want to say is, besides the autonomous vehicle, you can also see the sorting robots in distribution center. For example, if you go to the warehouse of Amazon and Alibaba, you can see there are all kinds of sorting robots there. Alibaba has also introduced the last mile delivery autonomous vehicle. They have a very good practice in Zhejiang University in China. That vehicle can even interact with people. Besides the traditional car makers, since the autonomous vehicle is such a good area right now, so all the big tech companies, including Apple, Google, Amazon, they all introduce their own car technology. And the reason that so many high-tech companies are interested in autonomous vehicle is because in 2019, artificial intelligence, autonomous vehicles, and 5G communication have been identified as national priority for future technology by the US government. And then you can see there is a booming growth of these areas. Next. Okay, so after we look at the importance of autonomous vehicles or the specific type of robots, let's look at what's the current situation on the road of the vehicles. It's reported that there are about 289.5 million vehicles registered in the United States in 2021. And overall, there are about 1.42 billion cars worldwide. The types of vehicles, including passenger cars, trucks, buses, motorcycles, rigs, and all kinds of other transportation vehicles. Since the number of vehicles increased so much, it caused severe and faster global warming problem caused by CO2 emission, especially when the vehicles are in idle status. There are more CO2 emissions than the driving status. The second problem is because the increase of vehicles on the road also leads to the increased number of injuries and deaths every day. Next slide, please. So it's reported that car crash is the #1 leading cause of death for teenagers. Every day, there will be 6 teenagers aged from 16 to 19 died because of vehicle crash, and hundreds of teenagers will be injured. Besides the safety concerns for teenagers, elderly and disabled people will have difficulty to drive a vehicle also. And the reason is it's very difficult for them to finding objects and making decisions. Next slide, please. To address these two problems, the first problem is the air pollution. The second problem is the safety concern. To address these two problems, people have proposed electric vehicles to reduce the air pollution. And US government released last year by President Joe Biden says we expect to have 50% of electrical vehicle sales in the United States by 2030. And also there will be around 4 million EVs, electrical vehicles in California, single state, okay? And also it was just last month, President Biden, BOT, DOE all announced there will be a $5 billion over 5 years for national EV charging network. So there is going to be a big thrust to invest in electrical vehicles and the charging network. So combining with the benefit of reducing air pollution, electrical vehicle also increase the driving safety because it's likely to roll over than the conventional cars during crash. Next one, please. And to address the second problem for the safety concern, people have proposed autonomous vehicle to do this. You can also think about autonomous vehicle with autonomous driving, okay? So autonomous driving includes both finding objects with cameras. However, these cameras will take images and process the image with the computers on the car. And the problem of this is going to be very expensive car. You can think about how much you pay for Tesla right now, okay? And also, the images and videos taken by the cameras on the car will be processed by individual car. It's pretty slow, and we cannot share the information around, among all the vehicles on the road. And another thing we want to say is autonomous driving is not just planning the trip, because you can see that millions of people are using the Google Map or online driving direction guidance. However, it's not the autonomous driving. Autonomous driving has to be based on each individual vehicle. And it's very hard because for each vehicle, if you want to have a safety while you drive, you have to follow the 3-second rule, which means when you look at the car in front of you, there should be 3 seconds when you count from your current position to the position, the car in front of you. And why we need this 3-second safety rule? The reason is within the 3 seconds, you need to make decision. You need to move your foot from the gasoline pedal to the brake. And also we need to have enough time to allow the vehicle to reduce their speed to zero, to avoid, or to a very low speed to avoid a collision. And it started that when everybody make a decision, it should count to 1 to 1.5 seconds. And then if you have 3 seconds, you only have 1.5 to 2 seconds to reduce the speed. Okay, so think about if you have, you're driving on the highway with 65 miles per hour. Okay, think about how long you're going to drive within that 2 seconds. So this gives a challenge of real-time decision-making for autonomous driving right now. Okay. However, as we said, if we use the onboard computer, it's slow, there's no information sharing. And if you want to know the surrounding information, we need to have some cloud computing. And then the cloud need information from collect information from the road and send the information to each individual vehicle, which is very, very challenging to meet the safety concern. Okay. And how can we address all of these issues? So right now, people has proposed the fast, accurate object funding with AI algorithm, and also the fast information sharing with 5G network, and also the real-time decision-making mechanism, plus the traditional vehicle. All of these 3 new technology like AI, 5G, decision-making, plus the traditional vehicle will guarantee we have a good autonomous driving. Next slide, please. So think about autonomous driving. People have been dreaming about autonomous driving for many, many years. And everybody knows there is a very famous Disney cartoon from Arabian, right? It was the magic carpet or the flying carpet. In fact, the idea of autonomous driving in the modern world was proposed by the United States in 1950s. And starting from there, people have been working so hard to make the research and application of autonomous driving. Next, please. Okay, so in the near future, many car models will release their autonomous assistants. Benz and Tesla already have their autonomous driving package available. And then within next year, many car manufacturers expect to have cars featuring steering, braking, and lane guidance. Within 3 years, Google wants to release their new technology. And within next 7 years, many car manufacturers will expect to have fully autonomous cars for sale. Though personally, I still thought about this one because there are also legal issues for either the autonomous driving will be allowed on the road or not. So think about it, if you have a car crash using autonomous driving, will it be your responsibility or the car maker's responsibility because you're using their autonomous driving technology? Until the legal issue has been solved, I don't think we'll see the real autonomous driving or autonomous cars on the road. But you can see because these highly advanced technology developed recently, all the high-tech companies are expecting to share a piece of cake for this big market in the future. Next one, please. So as I said, because we have so many tech giants in this area, you can see learning robots is not only for the competition or not only for interest. There is a big job market or potential for big market in the future. Besides United States, China also released the AI autonomous driving, of course, 5G network as their national priorities. So to introduce the fundamentals of robotics, I have classified, or everybody has classified 5 primary areas of robotics, including operatory interface, mobility or locomotion, manipulators and effectors, programming, sensing, and perception. So what I want to explain this is going to be, if you think about a humanoid robot, it must have, I think about human being, we must have sensing and perception, which is done by our eyes and programming is going to be done by our brain. Manipulators is more like your fingers, and mobility, locomotion is more like your brain control your legs and feet to walk. And these are the fundamentals for robots. But there is going to be one thing for robotics, operation interface, which is going to be specifically not for human being because we don't have operating interface, okay? But for robotics, we also need to have operation interface to allow the sensors sense the outside environment information and send to the computers to process. So that's an operator interface. So I used human being for the explanation of the four necessary components, and then only for robotics, we need an interface to sense the environment and then send the environment sensing information to the computers. And besides these five primary areas, there is one thing we need to say is integrating all these five components together as a product is a much more challenging job for teenagers. So that's the reason we want to introduce this course to you guys in the summer. Okay, so I think I'm done with my introduction, and I'm handing over time to Janet.
Thank you. And thank you very much for the presentation, Dr. Jean. Now we understand more about the history of the robotics, how robotics can help our daily lives, and what are the five primary areas for robotics. Lots of great information, and thank you again for sharing. And next, please allow me to introduce our teacher and the TA for our class. So Yi-Chen is going to be our TA for this class, and he has a lot of passion about robotics since he was a little kid. And now he is a software engineer working at the AI startup company. And I strongly believe he will be a great TA, and he will be the best friend for your kids who are going to join our robotics class this summer. And then we also have Mr. Chen, who's going to be our teacher for this summer class. Mr. Chen has 25 years of experience in automation, robotics, vision, and machine learning AI. And he also helped his son with a lot of robotics activities. So he is he has been coaching FLL and FTC. So with that, I will hand it over to Mr. Chen for him to give us more information about the class. And actually, before that, I want to ask you to give us a comparison, like the five key areas that Dr. Jean just mentioned, how that can tie back to the class you're offering to our class in the summer. And back to you, Mr. Chen.
Right. I think at the beginning, I want to give some of the motivation why we XCamp and we like offer the class. First of all, it's over years being the FL and FTC coach. I observe there less and less Chinese kids, second generation, attend the robotic competition. Way much more Indian American attend the competition. That's just like a trend. So that's I feel like robotics, AI, machine learning is a very important field. I think Chinese Americans should attend more. And number two is robotics is a lot of Chinese parents think, oh, robotics is very time consuming. It doesn't help my kids get into top Ivy school or top of the Stanford or MIT school. That's true in certain way because robotics is a very complex field. As Dr. Jin showed, there are so many different areas, so much hardware, software. It takes a lot of time for the kids. Like a lot of the kids I coach from a third grader all the way to high school, then spend 10 years work on the robotics. So what that's motivated me is, and then also over the not like a 6 year, I spent a lot of time in the take class. The part of my job helped me to I take another class from Stanford University, anything related to AI, machine learning, reinforcement learning, and the robotics related class. And I was saying, hey, why not we take the Stanford course, the way how Stanford training the kids to use the simulation to teach our kids to learn the robotics. Because otherwise, you spend a lot of time waiting for hardware, waiting for the complexity. The kids often lose interest because it's too hard. So I will in the fullness and I will talk about more detail why this can help your kids. Number three is there a lot of our kids is, they don't know, don't, so when they apply for the university, they don't know how to tell a story. Like, hey, I've been to robotics. Why you want to do computer science? And why you want to do robotics? Then don't know how to relate to the robotic to what's the future, what's different type of field. Like what Dr. Jin talked about, their user interface, their mechanical design, their control, their decision making, their algorithm. There's just so many things you can spin if you know what's how things work. Another our case, what I can say is they often do the try and error. Then waste a lot of time try to learn from the try and error. I think that what I want to offer the class is to teach your kids really how every single component, how every single module, how put everything together, how it work, why it work. And then when something went wrong, you know how to troubleshoot it. You're not just try and error. So that's kind of my strong motivation is to teach our kids to learn how things work. And also, we need to what's the future when they go to university. They know what I want, what are my interests. There's so many broad there are five different areas, and it's across many different departments in the university. They can figure out what I want to do for my future. So that's kind of my main motivation. So when you look at this slide, uh, so even though there are so many different robotic competition, but the fundamental how you design robot, they're not common stuff. So what we like to teach the kids, teach students, how how you do the UI, how do the interface, how to interface with the robot, and how to design the different robot for mechanical, how to design the push bot, right? And how do you program? How do you how do you read the sensor, read the input, and how to control the motor? So there are some common stuff we want to talk, and also there's some unique about FL. For example, the FL when you choose a part, you can only choose a limited called legal parts. Legal part. You cannot take the part from other place. Sometimes you can get disqualified. There are some special thing by FTC, normally use Java. There are some special by FRC and VEX. So we will talk about the common stuff. We also will highlight some special for different competition. Right. Next slide. So the syllabus, the details, we are going to 12 weeks. Every week there are 2 hours of lecture to talk about all the different subjects, and there are 2 hours to the lab. So the lab will be TA and me will work with your students, to hands-on to how to program individual module and then integrate all the robot together. So some key topic we want to talk about the sensor, how the sensor work, how they control, how to read the data from the sensor, and how the actuator work, and how they control it, and how they design the control, and then how they define different sub-module, the intake, how do you design your software, your robot can avoid obstacles. So if the iRobot move from one room to another room, how do you figure out? How they design the controller, PID controller, so that the robot can follow certain line, certain trajectory. And we want to talk about, as Dr. Jin talked about, system engineering, how to put everything together. They're not a full challenging part. How do you put all systems together, achieve the mission, and at a very limited time to get as much points as possible in the competition. And then we were and at all, we'll talk a lot about the robot design, but this class will still focus not on programming because kids are not the programming. So we will have a lot of hands-on teach your kids how to program every single components and control the whole robot, and then do the troubleshooting tuning. And then at the end, we will have the final project as well. Next slide. So some of the key components we'll talk about: sensor, the color sensor, the camera, or it's a sensor to the robot know how to sense the environments. Distance sensor, lidar sensor, so that you can figure out the distance from the wall or from any other object. And also we will teach the kids or different type of actuator, different type of motor, DC motor, servo motor. There's so many different and what's different. And for the different mission, different function, which one to choose. And so that will be, we'll talk about the sensor and actuator, how it work and how to choose, how to program and control them. Next slide. Control module, this is one example, FTC control system. So there are control hub. From a control hub, how do you wire towards the sensor and how do you wire towards the actuator? And then how do you do the mapping from the input output into your I/O so that you can use Java to program that. Next slide. System design. So we can start drivetrain. So how do you push bot design? For this one, is what we show is this push bot can move in any direction. So we will talk about how do you design such a push bot can move in any direction, and how do you program control this. So this is the same push bot depending on how do you send the output, how do you control the different output. You can choose a motion forward, backward, turn left, turn right, or diagonal. Next slide. So we'll talk about or break down the robot design to many different function modules. I use one example, intake. Intake is very common for any robot competition. You will talk about intake design. Doesn't matter FL, FTC, FRC, or VEX. The intake is a mechanism to pick up the parts, pick up the game elements, and also to score the game elements. So the intake normally you need one type of rotation motion powered by a motor, so you can pick up the parts. So normally just use one motor. And in the competition, often, for example, FL, you can only have five motor, so there are limited motor, so that the intake normally only choose you only consume one motor to achieve that motion. So when we talk about every module design, we will talk about some kind of principle and specification when you design the intake. For example, the intake, the reliability is very important. Just like the Dr. Jin talk about autonomous vehicle, there are sometimes some parts reliability very important. For the robot design, intake is very, very important. The reason why you are repeatedly to use your intake to pick up parts and score. And so there's going to force, there's the impact, there's going to collision with other robot. So sometimes when you do the competition, the opponent try to block you, sometimes can damage your part. So the intake is something is very important. You need to have very robust design. And sometimes you might want to design your intake to be retractable so that when the opponent try to destroy your parts, you can retract your intake so you don't get damaged. Right? So that's all the some things the student should learn. Some other criteria for intake design is consistent. So that your intake should work in all different orientation, gesture, or so that you can maximize your score opportunity. Doesn't matter where's your because when you control the robot in the environment, there's not uncertainty. So you want to improve your design to be more consistent. under any uncertainty, you can maximize your score. So that's what I call consistent. Some other things called controllability. That means even sometimes when you're in a situation, some of the parts piece get jammed. You somehow can figure out a way how to can recover from that. Something you can maximize your controllability. You can reduce the failure mode. And then the last one for the intake design, the efficiency. So the game of all the robotic design competition is you want to score. And for example, FL, every time when you pick parts, that's what some mission is about. You pick some parts. When you pick the part, you score 10 points, 15 points. So you want to you want to pick part as fast as possible. That's why the efficiency is what I normally say. For every part you pick up, it should be less than 7 seconds. So if you take more than 7 seconds, then you are not going to have very good design. So there are certain specification principle when you design the intake module. We also will talk about for different module, different function, and what specification, what type do and don't do some things a kid should learn. So that when the student, when you run a good competition, you need to think about all the stuff. When something doesn't work, when my performance doesn't work very well, then where I need to improve. So so you need to learn some of the fundamental that help you guide you to do the robot design, the program much more efficiently. Next slide. As I talked about the beginning, it's study robot is very time consuming. So what we XCamp we like offer is to use the simulation to help you don't waste your time to waiting for hardware design. You can use the simulation environments, and then you can learn all the different individual components design and the programming on the simulated environments. So ROS was invented by Stanford, two PhD students, and it's been widely used by the Stanford, MIT, world top engineer school, and also it's been used by industry. You can see it on the right side that all the companies start to use ROS. Amazon, 3M, ABB, then use ROS for the research, for the quick prototyping. The strength of the ROS is a very modular design. In the next slide, I will talk more detail. It's a very great simulation tool. You can simulate all you can do all the programming, troubleshooting, simulation in the virtual environment, and then you can deploy on a real robot. And then the outcome is more or less very, very close. So that can quickly speed up your prototyping. Then the most popular programming in ROS right now is Python and C++. There are also the JavaScript and also the Java supported, but most popular is Python and C++. There are a lot of reusable library and package so that you can build a very fancy system, but with smartphone library and packages from the ROS community. Next slide. So I want to talk about more the ROS, the modular design. So the ROS is the more distributed computation. So you have a lot of different nodes that talk to each other. For example, if I'm the sensor designer, I'm design a module to reading the input from a camera, for example. So I will talk to the camera, get an image, then I'll publish that image. Then you can have another teammate can design another module. Then the module just says, hey, I'm going to subscribe the image from the module I designed. So he will take the image, then he will use some machine learning, use some other machine learning library, then convert the image into an object. The object can be the part you want to pick up, right? So so it's very modular design. So everybody can debug in, coding in your own module and test in your own module with a unit test. So next slide. I want to talk more detail. For example, next one.
Time checking. We have 17 minutes left.
Okay, next slide. So for example, if in this class, there are one module talk about PID control. So you will have input in the position of your robot. And then, so how do you, from the position of the robot, and then the target, you know the target, here is the position. And how do you calculate your control? The control you will send it to the loader, right? So you will have input and you have output. So the student just need to focus on how do I design my PID controller. If you the middle school case, you won't just do the P controller. But if high school case, you can do integral and derivative. You design PID controller. So next slide. And the projects we're going to use a turtlebot string like on the right side to achieve the mission. The mission can be the give you a map. The robot need to navigate from room 1 to room 3, and they need some visualization use ROS and some bullet points for the high school kids can do the PID controller. You can use a computer vision, do the object detection. You can even design some finite state machine for the controller. And then also, we like this, our kids has a good presentation skill. So at the end of the project, every student will give us 3 minutes presentation about your project. Next slide.
Okay, this is me. Thank you. Thank you very much for the detailed information on the class contents. I hope now the parents and the students have a better understanding of what is a class about. Now let's talk about the class schedule and the price and how to register for the class. And also we want to save enough time for the Q&A. I'm sure there's a lot of questions from the parents who would like to get a direct answer from the teacher. So for the students, this class is designed for students from grade 6 to 12. And if you're XCamp students, it's recommended at least you'll finish the CS 101. And for non-XCamp students, don't worry, this is also the right class for you. Welcome to XCamp family. And we would recommend it for a student to have at least 1 year solid coding experience. It can be in any language. And the student will need to have good understanding of the basic data type and the data structure and the control flow. If you have intermediate and advanced algorithm, that's a strong plus, but it's not a requirement. And for robotics experience is also a plus, but not required. We will teach that in this class. And familiar with Linux is also a plus, not a requirement. That will be taught in the lab. So next is how much the class is and when the class will be held. So this is a summer session with 12 sessions, start in the beginning of June and finish the end of August. In that 12 sessions, it have 2 hours lecture time plus 2 hours lab. The lab, like teachers Chen said, it will be led by teacher and the TA. It is a very hands-on lab. So right now the class schedule is the class will be on Tuesdays evening and the lab will be on Saturdays. For the price, the class original price is $1,200, but this summer, since this is a new class release, we do have a promotion price which is $800. Plus, if you register before the end of this month, you'll get another $100 early bird discount. If you pay $700 for this class, it is less than $15 per hour, so which is a very good deal. With that, I think we finished today's presentation. Like I said, we want to have enough time for the parents and for the students who are here to ask questions. So please either unmute yourself so you can ask the question directly, or you can type it in the chat window. I can read it out for us. Any questions? Let me go to the chat room. Otherwise, please go ahead and unmute yourself. Okay, so there's a few questions. Let me go to the chat. So the first question from Mr. Yan is, where will the lab be? So Ms. Chen, do you want to answer that?
The lab will be, so we will, as I said, we will use the Ubuntu Linux environments, and then you will run ROS simulation environments, so that we will have the detailed instruction to tell the kids how to install the Ubuntu, how to install ROS, and then in the lab session we can help the student if you run into any issue. We make sure you have your own simulation environments.
I hope that answered your question, Lin Yaning. If not, please feel free to unmute yourself and ask follow-up questions. Here's another question from a pro gamer. Does VEX have camera? I only heard of some sensors. Do we know about that? The VEX.
Yes.
But there's William said there's some, yes, optical, but there's also distance intervals. What are the bumpers? But like,
the other questions Mike asked, but will there be a competition? Yes, there's a competition. So in the final project is a competition, because the robot is, even though the simulation, but it's a physical-based simulation. So the robot can have same uncertainty, the way there are friction involved, the slippery, the sensor might have noise. So you need a design, you need to program your software, your robot, to achieve the mission as fast as possible, right? So if I have the mission from robot move from room A to room C, full move faster will be win, right? So if it's a 30 second, everybody must finish under 30 seconds, but full choose the faster time, full will win the race. So it's a competition.
Thank you. There's a few more questions. One question from Kathy. She's asking to go back to the slides with the requirement for the camp. So Kathy, I did put it back to that slides. If you have any questions, please feel free to unmute yourself and ask. Can you guys unmute yourself, or like it's not, maybe we can try to unmute everyone. Maybe they could not unmute themselves. Maybe that's the reason. 1 second, let me try to. Oh, Tranji, can you try to unmute everyone? There should be a way to do it. But anyway, let me continue read the questions. The next question is this course online or in person? Is lab online? I can answer that. The course, the lecture itself, and also all the labs are online. But we can still do hands-on using simulation like Mr. Chen just said. The next question from Haiti Meng is, who will be giving presentation in each class session? 20.
So for the lecture, I will give the lecture every week, Tuesday, and then for the lab, either TA and me will both in the lab session. We probably need to do the breakout different to the breakout room if there. So we will break the student into different group. In order, depending on how many students attend, if there are too many students, we will break out the lab into multiple sessions. So there might be multiple lab sessions, and in every session we can break the class into different group and go to different lab session, because I do want to make sure every student has get help, because we are running in the Linux environments with ROS simulation. I want to make sure your kids get help, whatever help, real-time help you need.
Okay, thanks.
So I want to ask follow-up question on the answers you just gave us. This is Hattie, by the way.
Yep.
So you said that you're gonna teach the lab. You and the TA is gonna teach. You both are teaching the lab. So is there gonna be a official lecture kind of thing? So the teacher, like in the university, the professor will teach, and then you're gonna have a lab with a TA. So it's two parts, or it's gonna be one part, just the lab, nothing else.
Yeah, I can explain. Like there are two parts. The class itself, the lecture, the 2 hour session will be taught by teacher, which is Mr. Chen, who's here. So he's going to be the class teacher. So he's going to do a 2 hours class on Tuesday, I believe. Let me check.
Yes.
On Tuesday. Then on Saturday, there's a separate 2 hours lab. That lab, both teacher and the TA will be there to help students to do hands-on lab. Hope that answered your question.
Okay, got it. Thank you.
You're welcome. So we have quite a few questions. Again, if if you just like what Haiti did, feel free to unmute yourself and ask questions directly. Otherwise, the next question is from Jenny. From Gany, sorry. Will all class be taught online? I think we already answered the question. The answer is yes. The class, the lecture, and the lab are all going to be online. The next question from Mike is, will purchasing a physical kit be recommended? Trenchi, do you want to answer that question?
There are no physical kit you need. It's everything is free. Ubuntu is Linux environment free, and ROS is free.
He's asking about the physical kit. Since we are using simulation, there's no need for a physical kit for the bots, right?
Yeah, the turtle bot is a simulation too. So it's a physical simulation, the turtle bot. So that physical simulation model is actually very good. It's we actually in the Stanford A237A, when we program on the simulation, we deploy the robot. It works the exact same as the simulation environment. Is very real. So when you program on the simulation environments, there's no difference from you program on the real robot.
Okay, hope that helps, Mike. The answer is no, you don't need to have it. Everything will be a simulation. So the next question from Tracy is, how many commitment hours after the class? 2 hours lab is good enough? Is it after the 2 hours lab plus 2 hours lecture, does student have to spend more times?
I think this really depends on. I think that if the student who had the Python background, who doesn't have the C++ background, so if you want to learn C++, we will offer you help through the lab, but you probably need to spend more time to practice C++. So it really depends on your background, how much is the motivation you want to spend. You want to spend more time, we will offer you more guidance so you can spend more time, learn more. Because really at the end of the competition, in the project competition, if you know C++, you have advantage because C++ is faster than Python, right? And if we want to use more fancy PID controller, for example, we will help you how to design PID controller. But if you want to spend less time, you only do the P controller. You will not do as well as the people who do the PI and the D controller, right? So it really your it really depends on your students. If student has want to learn, you can spend a lot of time. But I would say for the XCamp student who finish one-on-one, if you spend 2 hours on lecture, 2 hours on lab, you can probably spend 2 to 6 hours per week. You can have the good. You can follow up with that class.
Thank you. So the next question from Yiming is, what is a class size?
As I think I answered at the beginning, the lecture will be the same class because we talk about lecture is, but for the lab, we will have a smaller lab size. I think we will be start with maybe the 10 lab session. So if there are 20 students sign up, we break it on 2 different lab session with we want to give the very small group size for the lab so that we can give the good help your students.
So if I understand you correctly, just recap to make sure we are on the same pages. The class size can be bigger than 10, but the lab size is more critical. We will have the size of 10 kids for each lab. We'll break the kids into different labs, so make sure everybody has time to do hands-on and get help needed. Is that correct?
Yeah, this is very common like in Stanford. You can have 500 students sign for the class, but then you have many sections, and every section has 10 or 20 students to go to the lab session. So we'll do the same model.
Amy, hope that helps. If not, please either type more to follow up or just unmute yourself, ask follow-up questions. The next question from Charles is, will there be homework after each class? How much time will students have to spend on homework? So I think you covered that, but do we have homework besides lab? I would think yes.
Yeah, we will have homework average probably 2 to 6 hours.
2 to 4 hours, I think.
Yeah.
And also, good news is no final or midterm exam. So it's homework after each class and also lab with hands-on and with a final project. But there's no midterm and final exam. But the average homework time will be 2 to 4 hours, depend on the background of each kid. Is that correct? I do not want to give
Yes.
the wrong information.
Yes. And then for every lab, you will get a very detailed instruction. And then most of the time, you can follow the instruction, you can finish lab yourself. And if you run into problem, any step will help you real time.
Thank you. The next question from Zhang Shu is, can XCamp help students build robotics groups for real competitions per their interest and levels? I will say this one has been brought up. It is on the roadmap, so we will consider that. But right now in the summer, the goal is to really develop and deliver a very solid class, which is XBoss 100. Going forward, if there's enough demand and interest, we can put that in a roadmap. We can try to offer that as a service. Anything to add on, Twenty, for this?
Yeah, good idea.
Okay. So the next question from Xin is, which competition tournament can student attend after this camp? So that's a good question, I think, if you want to.
I think that as we talk about in the presentation, we will teach the fundamental and the principle of the robot and autonomous vehicle. Really, that fundamental knowledge is common across all the different competition. So this is going to help all the kids who do FL, FTC, FRC, and the VEX. And even also this one is very important for students who go to university. So if you go to university, for example, you go to Stanford, whatever you take today is going to help you tremendously if you go to Stanford to take any class. Because a lot of this, what I learned from there, I want to teach the kids in the middle school and high school. So if you go to Stanford, a lot of stuff you already know ROS, you will be much more ahead of all your classmates in the future.
And if you don't go to Stanford, that'll help too. I just want to make sure.
It's not most schools, not school use MIT use ROS too. There's UIUC, they're not school, Berkeley, not school use ROS. And even if you look at job interview in Amazon to Boston Dynamics, probably not gonna ask you interview question about ROS.
Okay, I apologize. We are 3 minutes over, but let's do another 5 minutes if we can to answer all the questions. And the next question is, which competition Oh, we already have that. The next question is, my son is in a top FRC team for 2 years. He and his teammates have been working on drivetrain, intake, camera, and autonomous driving. Do you think this class is right for him?
I think for the kids who already did 2 years in FRC, probably will be in the last year of the high school. Your kids probably can put his time on something more useful, like start writing essay for content application. I would recommend them doing some research, some more than this.
So I think what Chanchi was trying to say, like that those we do have a plan to have three classes. This will be the first one, BOS 100. Then we have 200, 300. Once we go to 200, will be intermediate, then advanced. So for your case, your son probably will be in advanced class, or even doing research like Dr. Jean's research, like they also took like top high schooler who's going to go to college soon to do some research. So this class might be a little bit fundamental for you, but we can discuss after this
I'm
call.
changing my mind, depending on what you want. If you want your son to improve his FRC design, because he already did 2 years, he may not learn much. But if you want to prepare him to do well in the university, this might benefit him because he will learn ROS. He will learn C++ program. He will learn how to do the image processing, how to use computer vision, how to do the object detection. So this might help him with future university study. Might not help much with his FRC competition right now because he already done 2 years.
Yeah, I think I would suggest let's do a quick offline follow-up in case, if you want to know more about like how this program will fit your individual kids. So we can have that. We are 5 minutes over. Any questions we can take?
I have one more question. It's very this is Hattie again, sorry. I want to know, so this is a summer program for 3 months only, probably only 12 classes.
Right.
And then you also talk about you're gonna teach the kids so many different languages and so many different knowledges. I'm just curious. I mean, I'm not apparently a computer science major. I'm just curious how can the kids learn so many different things in such a short period?
That's a very fair question. So let me go to the syllabus part. So Tranchi, do you want to maybe give a little bit breakdown on how you're going to break those knowledge into each lectures?
So here in the pyramid, we have 5 key topics. So we are probably every 2 weeks we'll cover 1 major topics. So for the programming wise, we have the requirement your students already have been doing the program for over 1 year. So if the student already learned the Python for 1 year, to convert from Python to C++, that should not take much time. We were and a lot of for kids who want to convert from Python to C++, we are not going to spend a lot of time in the lecture in lab. We will give you the material you can study. We can help, but you will spend more time after class to learn yourself. So we want to offer as much resource as possible, but we will have core topic we will cover, but a lot of supplementary stuff the student need to learn themselves. We will help, but they need to spend more time after the class.
So the key knowledge, I would say knowledge point is on this slide, right? Like this is fundamental, or like the things you would make sure to teach the kids through the 12 sessions.
Yeah. For example, the PID controller, we will talk about key like proportional. And IND is more optional, right? So because IND is more derivative is more for high school kids. For the high school kids who want to learn that, we will help. But for the middle school kids who don't take the calculus yet, who don't know what's the derivative. But for the kids who had interest, even in the mid school kids, we will teach you how to do the integral, how to do the derivative, teach you the formula. You don't need to take the calculus to program PID. I even teach the elementary student how to design the PID controller. So what I'm trying to say is that we will help a lot of this the topics. We can cover the fundamental stuff, and then more extension. If the kids want to learn more, we can pour into additional resources you can learn.
Okay, and Chen Yi is asking for the time of the price slide. So here's a slide for you. Any other questions? I would like to respect everybody's time. We are 10 minutes over, but we can take one more question if there's any. If not, so for the next step, actually, we're going to send you the recording session, and at the end of the session, there's a registration form, and also we'll send out the registration form link to the WeChat group. So if you're interested in this class, feel free to register. And if you have any questions, please let us know. With that, if there's no more questions, thank you everyone for your time, and have a good Saturday night, and talk to you later. Bye.
Thank you. Bye-bye.